Now we're going to talk about page 5 in the Chapter 4 AP packet on oxidation numbers. You've probably heard the word oxidation before in conjunction with rusting. That actually just pertains to iron. So iron would be turning from regular solid, reacting with oxygen to make Fe2O3, because iron 3 is an orangey color and the oxygen is a -2, and they started off as zeros. So that's oxidation of iron, which is called rusting, whereas the Statue of Liberty also has been oxidized, which is plain copper. That has reacted with oxygen in the air as well to form the formula of CuO, which is cupric oxide, because copper is blue only when it is +2. Actually, +1 has no color because it has filled d orbitals, whereas copper +2 has partially filled d orbitals. So oxidation can mean gaining electrons, gaining oxygen, but it doesn't always have to gain oxygen. What it definitely always means is going up in charge or losing electrons. Those are both for sure true, whereas reduction is the opposite, gaining electrons or going down in charge. So gaining oxygen and losing oxygen are parenthetical. They're not always true, but they can be true. An easy way to remember what I just said is Leo the lion says grr. Leo means lose electrons oxidation, and grr means gain electrons reduction. So what we're going to do is we're going to learn how to assign oxidation numbers to every element within a chemical reaction. So the first two rules pertain to elements by themselves. If you have an element by itself that's not with anything and has no charge, it has a 0 oxidation number. If there is a charge on an ion, such as a lithium ion, then the oxidation number is +1. So those are elements by themselves, not combined with something. Now, when you're in a compound, you follow these rules, where group 1 is always going to be a +1, and a group 2 is always going to be a +2 in a compound. Rule 4, hydrogen is always going to be +1 in a compound unless it's a metal hydride. A metal hydride means it's with a metal. So the metal itself, in this case, is +1 for sodium in group 1. Therefore, the hydrogen actually is a -1 in this example. Oxygen is always going to be a -2 in a compound. However, in a peroxide, it's going to be a -1, which you can see matches up nicely in hydrogen peroxide. Remember that peroxide is a polyatomic ion, O2 -2. So since the whole thing is -2, then one of them is going to be a -1. Rule number 6, the oxidation numbers of a compound must add up to the overall charge. So, if you're going to look at NaCl, the overall charge of NaCl has to add up to 0. So you know that the sodium is +1, you know the Cl is -1, so therefore it matches up and adds up to 0. But sulfate, however, is a -2 altogether. So if you're going to do the oxygen first, that's the one you know, is a -2, then you could do the total down here. Okay? Don't put the total above the O. Always write just one of them there, and then the total can go down here. So the total for the O is -6. The whole thing has to add up to -2. So therefore, something plus -6 is -2. That's going to be a +4. So the sulfur is a +4. Okay, I just did that wrong. I'm sorry. I really don't want to start this video over again, so I'm just going to fix it. 2 times 4 is 8, so that's going to be a -8. All right? The sulfur has to add up to -2 with that. That's going to be a +6, so this is a +6. Now, if there were 2 sulfurs, then this would add up to 6. Then each one would have to be a +3, and you'd write a +3 over here. All right? So again, sulfur's +6. Sorry for that mistake. Now, number 7. Rule number 7. This is as a last resort only. Last resort only. The group 6 is going to have a -2, and group 7 is going to have a -1 in a compound. Let's take an example of how you would have to use this. If I gave you the formula NaClO, notice that Cl is not last in the formula, so you will not be using the last resort here. And you would only use the last resort if you had no other options. But we do have options because we know that sodium is +1. We know that oxygen is -2. So the chlorine must be a +1, which is probably surprising to you. But nonmetals can have a lot of different oxidation numbers. So therefore, this is going to be +1. A last resort situation would be something like CuCl2. Now, you know copper is either +1 or +2, and you have no idea which one it is. So you'd have to understand that the chlorine must be a -1 here. So therefore, the copper must be a +2. So last resort means it's last in the formula, and it means you have no other options, but you have to use a -2 for group 6 or a -1 for group 7. Now let's use our rules to assign oxidation numbers to these last 3 equations on your paper. We're going to start with silver nitrate. Now you know silver already is +1 because of the 2, 2, 1 on the periodic table. You know oxygen is -2 from the rules. So this sum is going to be -6 and +1. Something has to add up with that. It must be a +5. So nitrogen is +5. So here I just did the whole thing at once. I didn't even care about nitrate being a polyatomic ion. If you wanted to, you could use nitrate by itself and figure out each element by itself. So if the oxygen is -2, that's a -6, and something with that has to add up to -1, that must be a +5, so you know that the nitrogen is now a +5. So either way is fine. The copper by itself element must be 0. Here, we know nitrate as a whole is -1, so that tells us the copper is +2, and we already figured out before that N is +5 and O is -2 in nitrate, so once you know that, it's always going to be true. And an element by itself here is 0. Next line, chlorine is going to be element by itself, so that's going to be 0. The H is +1, so the Br must be -1. Here H is +1, Cl must be -1, and element by itself must be 0. Last line, we're going to see that the calcium is by itself, that's a 0. Chlorine is by itself, it's a 0. Here group 2 must be +2, so the chloride must be a -1. And what we realize in each of these examples is that one element goes up, being oxidized, one element goes down, being reduced, and that's called a redox. So the silver here went up, the silver went down. The silver went down from +1 to 0, and the copper went up from 0 to +2. So when you go up, you're oxidized. When you go down, you're reduced. All right, now look at this one. The chlorine went from 0 to -1. That's going down. And the Br went from -1 to 0. That's going up. Lastly, the calcium went from 0 to +2. That's going up. And the chlorine went from 0 to -1. That's going down. Okay, so whenever you go up, you're oxidized. Whenever you go down, you're reduced. One more vocabulary term that you need to understand is the agent, reducing agent and oxidizing agent. So if you get oxidized, you are the reducing agent because you made something get oxidized. You made something get reduced. When you get oxidized, you make something get reduced and you're the reducing agent. When you get reduced, you're the oxidizing agent because you made something get oxidized. So to sum it all up, the copper got oxidized, it's the reducing agent, and the silver in silver nitrate was reduced and became the oxidizing agent. Okay? It's always the left side that are the agents. The left side, because they're the ones reacting, these are the products. So if you get oxidized, you're the reducing agent. If you're reduced, you're the oxidizing agent.